In this video, I'm going to show you the new NFS Turn Wizard. This is the Newfangled Solutions wizard for turning, and it's much like the Newfangled wizard for mill in that you can combine many simple operations and generate one more complex G-code program. Let's begin. It's like all wizards. You select from the Pick Wizard screen. This one is called NFS Turn. I say run, and we come into the NFS Turn screen. This will be the initial screen that you'll always see. Notice the wording up here, licensed version. I have a license installed on this system. If you don't have an NFS license, this will say demo version. You can still run the program, but you can't save a file. When you exit from the wizard, your file will be deleted. But you will be able to run the interactive mode operations. The top of the screen has all of the standard things you need to know about a lathe, your DROs, whether you're in diameter or radius mode, your feed settings, and notice this setting can be changed to whether you're running in inches per rev or in inches per minute. But this is your feed rate settings. These are your spindle values, and a few settings that we need, like the jog controls to turn jog on and off, to change a jog mode, and a couple of coolant buttons and spindle buttons, although these probably aren't needed because the code will do those functions for you. You notice kind of two rows of buttons. These buttons let you run the system in manual mode. The manual screen would be where we'd go to set up, referencing the machine and setting the home coordinates up. The tool offset screen, a little complex here, but this is the same as in the standard Mach lathe screen set, and this is where you would go to set up a tool offset in the tool table. If you had a tool changer, or even if you're changing tools by hand through something like an Aloris tool post, you'll want to work through this screen and set up your set of tools that you're going to use. I won't explain how to do that here. The Mach lathe manual has that pretty well covered. So this is the screen that you would use to set up your tool table. This is the run screen. When we're ready to run a program, this is where we'll go. We have a G-code, a display window and a G-code window. We show the limits of the size of the G-code, a handy help to make sure you're not running off the screen somewhere. And the buttons will need to be able to start and stop the program and load and edit the code. There are a couple of diagnostic screens. These probably aren't very useful. They're here because at one time I had thought about making this wizard a screen set instead of a wizard, so they're probably not very interesting here. The real interesting ones is the second row, and they're somewhat in order. The basic idea here is that we're going to create a file, and we're going to compose the file of various operations, like a tool selection, a facing operation, a turning operation, a threading operation. We'll go through a couple of these and show you how they work. But we'll almost always begin with a file operation. And the file operations we have, we can start a new file. And if I click Start New File, we get a warning box says, do you really want to delete your old file? And I'll say, yep, really want to do that. So we have started a new file for this program. There are a couple of other operations we can do here. We can list the operations that are in the file, or we can delete the last one that's been added to the file. And when we're all done, we'll be able to come here and end the file. One interesting thing I've added here is that when we started the file, the program read a file in the new NFS Turn Wizard folder called G-code init. This is where a user can install any common code you want. I'll be initializing it and including the necessary code, but if you have something special on your machine, say you have some, I don't know, warm-up macro or some startup process that you want to go, there's a file that you can now insert that G code, and every time you build a file, that lump of G code will automatically be included. It's in your NFS turn folder. Similarly, when you end the file, I'll look for a file called G-code end, and any code that's in there will be inserted into the file. Now the wizard is going to apply an M30 at the end of it all, which is the normal end of code, so you don't have to do that in your G-code. This would be just anything unique. For example, you may always want to send your tool home to some special location at the end of a program. So that's two handy features that were added to this. Well, let's get started. Let's design a bolt that we want to make. This is going to have a shoulder bolt. We'll first select the tool. I'm going to use tool number 1 with offsets number 1. My feed rate is 4 thou per rev. I want to run at 800 RPM. Okay. I do not want to run the spindle in the reverse direction, or I don't want to turn on my coolants. Now, if I wanted those, these are toggle buttons. I could toggle that, and now I'll use reverse instead of forward, or I can turn that back off. So we do have the ability to add these functions if we want them. We also have the ability to give a name to this tool. We get a window pop up and we can type in a name here, like, I don't know, I might just call it side tool, for a tool that's going to cut on its side. Oops, yeah. So I could enter a tool name if I wanted. It's just for convenience. The other thing is a safe position where the tool can go before the change occurs, and it'll move X first or Z first as specified. So I've specified a tool. Now I could do that right now if I wanted to, although it doesn't make much sense to just do a tool change before I do anything. But probably I will want to click this button that says Add to File. Okay, so that has now added a tool change function into our file, which would be a logical place to start. Well, let's say that we're first going to face off our stock. We're going to start our facing operation inside at 0, and we're going to come out to 0.5. These could be reversed. If you like to face from the outside end, then put start and end in the right order for the way you want it. Z start, notice in this case I'm starting at a positive value and I'm going to finish at Z0. So this facing operation is going to clean off the end of my stock, leaving me with the end of the stock at exactly Z0. Z retract is how far I want to back the tool off between each pass, and Z cut depth is the depth of cut I want to make. Now I have two choices here. If I wanted to see what this operation does, I can click the Do It button. I will immediately appear in the Run screen, and notice I'm seeing just that facing operation. I do see the spindle start information, and then I'm going to see the facing operation. In this case, it's going to take 2 cuts of 50 thou each, and that's the condition that I want. I could click the Run button now and run this immediately on my lathe. So I could face off some stock by doing nothing more than filling in those blanks, coming to this screen, hitting the cycle start. It's wanting a tool change. It'll start, and we'll see the process is running now, facing. Remember, I said I was going to face from the inside out. Here's the second pass going on. Retract. Here's the final pass at the finished depth that's going to be made. Back off and stop. So I've just done that operation in my lathe. Let's go back to the facing screen and let's add that to the file. So now I've added that facing operation to my file. Next, let's turn to a diameter. Let's make our first cut at 460. Remember, we assume this is a 1/2 inch stock we're starting with. Let's end that at 310. The X retract, again, I want to back off 1/10 of an inch, and I want my cut depth to be 40 thou. I want to start Z at 0, and I want to end at a -1. Again, I could hit do it, come to the screen, I'll see the immediate thing, and I could execute this code right now. I'll skip doing that. I'll return to the turn screen, and I'll add that to the file. So now my file has two operations. It has a facing operation and a turning operation. Let's finish this bolt by doing an OD threading operation. And I have a bunch of parameters to fill up, and one thing I've added that I think is kind of neat is I have a thread table. If I click this button, a thread table will pop up, and unfortunately right now I don't have an appropriate thread for this diameter, but I'll pick 1/4 20. I want to put a 1/4 20 thread on this thing I've just turned. So I enter that, and you'll notice that the values get updated appropriate to a 1/4 20 thread. The thread table is a user editable table. It's just a text file. The first line tells you the order that the values need to appear. So if you don't like my choice of threads, then go edit the thread table and put in whatever threads you commonly use. Again, I could do this immediately, or I could do an add to file. Okay, well, for this purpose, let's say that we've done enough now. We've built a file, we opened it, we selected a tool, we faced, we turned, we threaded. I probably forgot I should have done a tool change in between the facing and threading. It's quite likely I would want a different tool for threading than facing, but that would have just been going back and selecting a tool. Let's go to our file operation now just to see we could do a list. And our list says that we started a new file, selected a tool, did a facing, did a turning, and did a thread operation. Okay, well, let's end that file by clicking end. Now remember that not only did I put the M30 at the end, but I read that G-code end file and included anything that it had in the end. So I've created a file. Let's go to the run screen and see what that file looks like. Well, kind of a strange looking picture here, but let's read down through the code. We have the information that a new file was started. Here's our user supplied init code. I've just put a G54 in just for fun. A new tool was selected. It was called side tool. Remember that I let you enter that name. There's the coding about changing the tool. Then I did a facing operation with these parameters. Notice I fill in all these parameters in the code. This makes a great debugging and also shows you what the code is going to do. So there's some operation that's doing my facing operation. Now I entered the turning operation. Again, the parameters are in the code, and there's the actual running of the code for doing that for last pass. Then I did a threading operation. Again, the parameters are explained in there. There's my threading code all filled out. Then I did a file end, and there's my user supplied end code, which in this case is blank. So that's what I've done with my wizard. I've created a series of operations, combined them all together. I could have run them individually directly in interactive mode. Besides the ones I looked at, we have an, OD threading we looked at, we have a chamfer operation that can just go in and click off the corner and at 30, 45, or 60 degrees. We have some internal operations. We can do a chamfering on an inside. We can do an OD taper, where we taper the outside of a piece of stock. We can do a cutoff operation, a parting tool coming in and cutting off at a particular location. We can do drilling operations, continuous peck or peck retract, and we can do a boring operation. I think these are the standard kind of fundamental turning operations. We have the ability to put them all together and make a single program out of it. This wizard is a newfangled wizard. If you already have the newfangled license for mill, you have everything you need to run this wizard. If not, you can go to the Mach support webpage and purchase a newfangled license, and you'll be able to run the program and save the code. So that's it for a demo for the NFS turn package. Hope you enjoy using it. If you have comments or suggestions, go to the Mach support forum and let me know about it. I'm certainly willing to make additions to this program as we decide they're necessary.